Okay, question 4, 4 marks overall. So figure 4 shows a block of mass 4m kilograms and a particle of mass m kilograms connected by a light inextensible string passing over a smooth pulley. The block is on a horizontal table and the particle hangs freely. The part of the string between the pulley and the block is horizontal. The block slides towards the pulley and the particle descends. In this motion, the friction force between the table and the block is 1/2 mg newtons. The question answers to find expressions for the acceleration of the system and the tension in the string. Okay, 4 marks altogether. So, first of all, let's put in the forces that we know. So, as far as the block is concerned, we know that tension in the string is moving it to the right. Now we know there is a resistance force, which is the friction of 1/2 mg. Now for the particle, we know tension is acting upwards, so it's trying to pull the particle up, but the weight of the particle is pulling it down. Now the weight of the particle is the mass, so m times gravity, mg. Okay, so now what we're going to do for each of the block and the particle is form equations of motion. So, by Newton's second law, we know that force is mass times acceleration. So, for the block, we know the force is acting to the right. We know overall the block is moving to the right. So we can say then we also know the mass of the block is 4m. So we can say that the tension minus the friction, so minus 1/2 mg, is equal to the mass of the block, so 4m, times the acceleration. And then for the particle, we can say the force, well this time the particle is moving down, so we know overall we're moving downwards. So for the particle we say that mg minus tension, because we know the weight is winning, the tension is losing, so we take tension away from the weight. So we know that that is equal to the mass of the particle minus, the mass of the particle times the acceleration. So that's ma. Okay, so we want to get an equation, first of all, for the acceleration. So if we label these equations 1 and 2, we're going to cancel out tension. We are going to add them together. So 1 add 2. So t add minus t cancels out. Minus 1/2 mg add mg is 1/2 mg. And that is equal to 4 ma add ma. So that's 5 ma. Now, both sides have a common factor of m, so we can say 1/2 g is equal to 5a. So we can then say a is 1/10 times g. And I guess we should put units, so that's meters per second squared. Okay, so now that we know that, we can work out an expression for tension. So let's use this bottom equation. So we know then that mg minus tension is equal to m times a. So m over 10 g, or mg over 10. So if we add t and subtract mg over 10, we get mg minus mg over 10 is equal to t. Now mg minus mg over 10 is 9/10 mg. So tension is 9 mg over 10 newtons. Cool.